Alright, so very good morning to everyone. A very good morning to all of you, my dear students. A very good morning to all of you. So, guys, I hope you can see me and hear me properly. Yeah, so very good morning to everyone. A very good morning to all of you, my dear students. A very good morning to all of you. So, I hope you guys can see me and hear me properly, beta. So, my name is Dr. Shankar Sir, and in this session, what we are going to do. In this session, we'll be having a revision of the 4 chapters. Okay, so in this section, we'll be talking about the chapters of units and measurement. Okay, that is your second chapter of class 11 physics. Then we have a revision of motion in a straight line. We'll have revision of motion in a plane. Okay, and we'll have a revision of properties of solid. Okay, guys, so in this session, we'll be revising these 4 chapters of the physics thoroughly, and we'll see that if we understand all the concept of it. So, I'll be a little quick in this session. Okay, so basically, when we start with the units and measurement, so the live students, welcome to the session. A very good morning to all of you, and I hope you are ready for this session. Okay. Oh yeah. Hello, Tanu. So, in the chapter of units and measurement, the first thing that we must know about is the physical quantities. Okay. So basically, this chapter give you an insight of the whole physics, that what we are going to deal with in the physics and what is waiting for us in the physics, right? Now, when I say units, physical quantities, okay, there are 3 kind of physical quantities. One is fundamental, okay, one is derived, and one is the supplementary, right? One is the supplementary, right? So in the whole physics, you are going to see these 3 kinds of quantities, right? In the whole physics, we talk about these 3 types of physical quantities, and basically, what is the use of? What is the use of? What is the use of the? What is the use of this? Okay, physical quantities. So basically, physical quantity serves as a language. Okay, physical quantities basically serve as a language in which the physics is interpreted. Okay, it is served as a language. It is served as a language in which the physics is interpreted. Okay. 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 So what are these fundamental quantities? So the fundamental quantities we have. So basically, as I was saying, so these physical quantities are the means by which the physics is is spoken, or the physics is interpreted, right? So physical quantity serves as the language to the subject. Okay. Now, what are the fundamental quantities? The live students can tell me, beta. So we have the length, Okay, we have the mass, we have the time, right? We have the temperature, we have the current, okay? We have the luminous intensity, we have the luminous intensity, and we have amount of substance. We have the amount of substance. Okay, so basically these seven quantities serves us as a fundamental quantity. Okay, like if I say of the English language, what are the fundamental of the English language, sir? We have alphabets. Okay, we have 26 alphabets, and using those alphabets, we make the whole English language. Now, similarly, this is what we mean by the fundamental quantities. So, fundamental quantity is something using which any physical quantity can be made. Okay, or I can say that any quantity like any derived quantity, be it anything, volume, velocity, force, pressure, stress, okay, magnetic flux, resistance, voltage, anything, be it anything, right? Be it anything. So basically all these quantities, okay, which are further derived, okay, are derived from these basic seven fundamental quantities. Okay, I hope it is fine to everyone. Okay, so now, so first of all we must understand the unit of these fundamental quantities. So this is meter, kg, okay, time is second, temperature will use Kelvin, current is unit is ampere, luminous intensity is candela, amount of substance is mole, right? So basically these are the units to these fundamental quantities. Okay, okay, and see, we are going to talk about the dimension also. So the dimension to these, how we represent the dimension. Okay, so L is represented like this, M is like this, M, time is as T, okay, temperature as Kelvin, okay, or sometimes, so because see, we cannot use T here, na? We cannot use T, so we use K, or sometimes we use theta, right? So this is how we represent the temperature. Current we use I or A, okay, I or A. Right. For luminous intensity, we represent it as CD, and for amount of substance, we represent it as mole. Right. Now, coming to the derived units. So, guys, as the name suggests, derived units are the ones which are derived using the fundamental quantities. Okay, so these are the physical quantities derived from the fundamental quantities. Okay, like length, mass, time. So you can they are infinite. Okay, you cannot have them counted. So these are basically countless, right? Any physical quantity which is made up of the fundamental quantity is what we call as the derived quantity. Like for example, if I say area, okay, so you will say that area is length into width, length into width. Okay, so basically length unit will be meter, width will be also meter. So width is also in a way representing the length only, isn't it? So basically here you will see that so anything more than the fundamental quantities when used, right? Like in this case, the length is used twice. Okay, so the unit becomes meter square, right? The unit becomes meter square. So area is a fundamental, area is a derived quantity. Like for example, volume, if I say volume, so you will say, so it is length into width into height. So what will be the unit? It will be meter cube. Isn't it very simple? We know all these things, right? So basically any quantity which made up of the fundamental quantities or which is more to the fundamental quantity, it could be a combination of different fundamental quantities or same fundamental quantity used more than once, make it a derived quantity, right? Like for example, velocity if I say, or speed if I say, it is what? It is displacement per unit time. okay, or change of displacement upon change of time, right? So somehow it is displacement per unit time. So displacement denotes you a length, okay? So this is the fundamental quantity will become length, and time is the fundamental quantity, that is second, okay? So it is meter per second. So basically in velocity also you are using, more than one fundamental quantity. So any quantity which consists of more than one fundamental quantity, or a fundamental quantity used more than once, is what we know as the derived quantity, and these are countless. The whole physics is made up of these only, right? Like for example, like in today I targeted to give you a revision of motion in a straight line, motion in a plane. So motion in a straight line, motion in a plane, and you see the properties of solid. In all these topics, what we talk about, what are the terms we use? So sir, we use velocity, acceleration, right? We use stress, we use Young's modulus, right? We use energy, strain energy. Okay, so all these terms that we happens to be we are going to use. Okay, okay, so these are only derived. Okay, these are derived from these fundamental quantities, and these quantity helps us to understand some physical phenomena. Okay, so I hope this is fine to everyone. Now supplementary quantities. Okay, what are the supplementary quantities? So supplementary quantities, basically there are two kind of supplementary quantities. There are two supplementary quantities. One is angle and one is solid angle. So you can call it plane angle also. Plane angle, only angle, it's same thing. And the solid angle. Okay. So see what is so special about these angle or the solid angle. So basically when we are talking in the SI unit, okay, System International Units. Okay, so when we talk about these, this plane angle and solid angle, so they do have the units. Okay, radian, and what is the unit of the solid angle, sir? It is steradian. Okay, steradian. So see, solid angle supplementary quantities like angle, solid angle. So these are the quantities which are having the units, but they do not have any dimension. Okay, so what is so special about the supplementary quantities? So supplementary quantities are the only ones. Okay, supplementary quantities are the only quantities which have units, but have no dimension, which have unit but have no dimension. Okay, they have unit but no dimension. Are you getting my point, Vidas? So see, having no dimension, what is the meaning of it? So having no dimension, it means that these quantities are not represented in terms of any of the fundamental quantities we have stated just now. Understood, Bida? Understood? So basically, what is the so supplementary quantities are the only quantities which are having the units, but they do not have any dimension. But they do not have any dimension. I hope it is fine to everyone. Right? Any issue? The live students. Now, when we talk about the dimensions, so see, uh, when we talk about the dimensions, basically, what are the dimensions? And what is the use of dimension? So see, dimension have multiple use in physics. It helps you derive the formulas. It helps you understand the physical, phenomena, right? So it helps you in a lot of ways. But what is dimension? So basically, see, I'll just explain. I'm not going to, give you a definition, because see, this is a revision session. So I'll be telling you the things which will help you, cracking down the questions, right? So what are these dimensions when we talk about? So dimensions basically, like for example, we have spoken about the area. So what is the unit of the area, sir? It is meter square. So from the unit of any physical quantity, you can write the dimension of it. So see, although we have 7 fundamental units, or fundamental quantities, and any physical quantity can be represented in terms of these. Though we mostly use the first three, length, mass, and time, because it has been observed, or you are going to see this, that most of the physical quantities are somewhat related with these three fundamental quantities, okay, or these are in majority related with these three fundamental quantities, that are L, M, and T, that is length, mass, and time. Okay, so these are three most frequently used fundamental quantities. So if I want to represent this area, if I want to represent the area, so how I can represent it? So see, mass, it has nothing to do with the mass, so we can write mass 0. Okay, then it is having meter square, so it is having length is square because it is meter square, and it has nothing to do with the time, so T0. Right, so if I ask you the dimension of the area, how you must tell me? So you must tell me that the area is having the dimension of 0 on mass, the dimension of 2 on length, and dimension of 0 on time. Dimension of 0 on time. Okay, I hope it is fine to everyone. Okay, like for example, if you want to represent the velocity in terms of the dimension, see, if you have the unit of something, basically you have the dimension, or vice versa. If you have the dimension of something, if you have the dimension of something, if you have the dimension of something, you have the unit of that thing. So if I say velocity is displacement per unit time, that is meter per second. So how can I have it represented? So mass 0, length meter, and time is t minus 1, right? So this is a dimension. This is how you represent the dimension. So same way you can represent the dimension of any of the physical quantities that helps you understand the physical world. Okay, okay. Now what kind of a question they ask you? So I'll just tell you. See how they framing the question. So they may ask you the first type. I'll write type 1. Okay. So the first type of question that they may ask you, from here, so it is to derive unit of some physical quantity, okay, or they may ask you to derive or get the dimension of some physical quantity. So see, it is very very easy. If you know the formula of some physical quantity, you will be able to get the you will be able to get the unit and dimension of it. See, very simple. So very frequently asked question is, uh, what is the dimension of universal gravitational constant? Okay, so like, see what happened when we start our journey in the 11th. Okay, so this is the first chapter, with first proper chapter. First chapter is the physical world, and that is a philosophical chapter, right? It has hardly helps you in the physics, right? Okay, so see, the real first chapter that we believe is the units and measurement. And in this chapter, you are given, an insight. You are given a lot of formulas, a lot of expression that you actually going to see in later chapters. Okay, like in for the chapters, you are going to see the physical quantity. In 12th, you are going to see the physical quantities. But what happens that they ask you to derive the formula of few. Okay, so if you see the question, they may give you the formula themselves firstly. Okay, so now to find the dimension of universal gravitational constant, so what is the formula? So force is g1 gm1 m2 r square, right? This is the formula of the gravitational force that we see, isn't it? The live students can respond to me. So can you get me the unit of the g and the dimension? Can you get me the unit and the dimension of this universal gravitational constant? Can you get me the unit and dimension of the universal gravitational constant? The live students. Can you tell me something about on this? So the live students, welcome to the session. My name is Dr. Shankar Sir. So what is going to be the unit of this universal gravitational constant? So what is the unit of this force? Sorry. So the unit of this force is Newton, right? What is the, see how we are writing? So we see simply we can find the unit, or from the unit we can simply find the dimension. Okay, so see, Newton for force, the unit is Newton. R square, it is meter square. Okay, and m1 m2, it is kg square, right? It is kg square. So Newton itself is a derived unit. So this is the unit of this g, right? Newton meter square kg square, and Newton itself is a derived unit. Like for example, force is equal to mass into acceleration, we know. So mass acceleration is what? So if I write the unit of this thing, so see, unit of mass is kg, right? Unit of acceleration is meter per second square. Meter per second square. Right. So see, if you want to show it in terms of dimension, and also you must memorize the dimension of the force. Why I'm saying so? Because see, force is a very important physical quantity. It helps you get different other physical quantities as well, isn't it? It helps you getting the different other physical quantities as well. Like so many quantities are dependent upon the force. For example, this universal gravitational constant, right? For example, pressure. For example, stress. For example, Young's modulus. So many physical quantities depends in a way on the force. So you must, memorize it. So F is equal to ma. So mass is in kg, acceleration is in meter per second square. Right. So see what happens. So can we write it like this? So for kg we have m, for meter we have L, and for second square it is T minus 2. So the dimension of the force is MLT minus 2. So actually you must memorize this. Actually you must be memorizing it. Okay. Okay, so F is equal to MA, that is MLT minus 2. So we can put it here. See, if we want to find the dimension of it. So see, for Newton we can write right away MLT minus 2. Okay, then meter square, that is L square, upon kg square, that is m square, right? So what is going to happen? So we'll be having m minus 1, right? Simple algebraic calculations. Then we have L cube, and we have T minus 2. Understood, beta? Understood. So what is going to be the dimension of the universal gravitational constant? It is going to be MLT minus 2. Understood, beta? MLT minus 2. So if you are asked about the dimension of any physical quantity, you must know its formula. If you know the formula by simple algebraic calculation, you can have the unit also, and then you can have the dimension also, or vice versa, right? Okay, so this is, you see that you will be asked about the questions of these, right? So if you want to like do more questions, see on this channel you will find PYQ sessions, practice question sessions on this topic, units and measurements. So you can go there and you can do, right? Okay, now just one more. So get me the unit and dimension of coefficient of dynamic viscosity. Coefficient of dynamic viscosity. Okay. So what will be the unit and dimension of the coefficient of dynamic viscosity. You please try that. This is again a quite frequently asked thing. Please go for it. Please do. Please do it. Please try to solve with the live students. So see, to find the, as I said, to find the unit and dimension of something, you are required to firstly have the formula for it. So see, if you go to see the Newton law of viscosity will have tau is equal to nu du by dy. Tau is equal to nu du by dy. Right? So the shear stress is equal to nu du by dy. So this nu is what we call as the coefficient of dynamic viscosity. This is what we call as the coefficient of dynamic viscosity. So this shear stress is Newton per meter square. Okay, nu du is meter per second. Okay, this is meter per second and dy is meter. dy is meter. So the unit of the nu is Newton second per meter square, isn't it? Newton second per meter square, right? Okay, so once you have the unit of something, you can obviously get the dimension of it. Okay, once you have the unit of something, you can have the dimension of it. Okay, and vice versa. So see, what will be the dimension to it? For Newton, it is mlt minus 2. Okay, for second, it is t. Okay, for second, it is t, and this is L square. This is L square. So this will become m L minus 1. Okay, and t minus 1. Right? M L minus 1, t minus 1. So see, Very simply, we can find the dimension of something like this. Okay. Now coming to the next part. So see, now you will see the question on the use of principle of dimensional homogeneity. Okay. Now what is this principle of dimensional homogeneity, guys? So see, principle of dimensional homogeneity simply means, okay, so see, it is, like something that we already know. Okay, so what we know. So what is the principle of dimensional homogeneity? So principle of dimensional homogeneity means that only those quantities can be added or subtracted. Only those physical quantities can be added or subtracted which have the same dimension. Okay, having the same dimension means they are having the same units. Okay, so see, you see, obviously, see, if I ask you that can you add rupees and second, can you add money with time, right? No, sir, we cannot, right? If I ask you, so what will be 100 rupees plus 10 seconds? 100 rupees plus 10 seconds. So you will say, sir, it makes no sense. How can we add rupees and second? Why we cannot add? Because obviously this is common knowledge, this is general understanding that you cannot add two things having two different units, right? Now this is what we know as the principle of dimensional homogeneity. Okay, like for example, see, let's suppose we are having a relation v is equal to a plus bt. V is equal to a plus bt. Okay, now when we have equation v is equal to a plus bt, and see, according to the principle of dimensional homogeneity, the dimension of each of the term must be same. Okay, like for example, whatever is the unit or dimension of the v, the unit of dimension in A must be the same, and this whole thing combined must be having the same dimension. So if they ask you that what is the unit of A, right? What could be the possible unit of A or possible dimension of A? So how we can write it? So see, simply dimension of A is equal to dimension of V, right? So V is the velocity. So what is going to be the dimension of A? So the dimension of A is going to be LT minus 1. Okay. Now similarly, the dimension of BT is equal to the dimension of V. Is equal to the dimension of V. So from here, the dimension of B, how can we do? So simple algebra. Dimension of V is LT minus 1. Dimension of T is T. So it shall be LT minus 2. LT minus 2. Now once you have the dimension, once you got the dimension, you can obviously interpret the quantity. You can obviously interpret the quantity as well, isn't it? Okay. Is it understood or not? All the live students, please answer me. So what could be the A? So it is having a dimension of LT minus 1. That means it must be meter per second. That means it must be meter per second. So it must be meter per second. That means, okay, it must be meter per second. That means that it is some sort of a velocity. Now similarly, the dimension of BT. Similarly, the dimension of B is LT minus 2. So it must be meter per second square. So it must be the acceleration, right? Okay. Now let's try one thing. So let's say x is equal to a plus bt plus ct square. Okay. plus dt cube upon e plus t. So now if I ask you that tell me the dimension, so x is a displacement. X is a displacement. So if I ask you what is the dimension, what is the dimension of A, B, C, D and E? So what you are going to tell me? Can you please answer me? Please tell me what is going to be the dimension of A, B, C, D and E? Please answer it, guys. Any live students who want to answer this? Can you please answer it? Please try to answer, beta. So see, very simple. See, each of these terms, and when we say a term, the whole thing that is separated by the sign of addition or subtraction. This is one whole thing. Hello Shivram. Welcome to the session. My name is Dr. Shankar Sir. So, my dear, in this session, we are trying to have a revision of the things we have read before. Okay? This is what we are trying to do. So, would you like to try the question? Hmm? Yeah, Shivram. So if you have any question of these chapters, you are most welcome. Yeah, I'm just explaining. So see, in this question, my dear, we are asked to find the dimension of A, B, C, D, and E. This is an expression x is equal to a plus bt plus ct square plus dt cube upon e plus t, and we are interested in finding out the dimension of a, b, c, d, and e. Okay, so these are some sort of a physical quantities, and we want to find the dimension of each of it. This is the question. Would you like to try the question? Would you like to try the question, my dear? Yeah. Ah, yeah, sure, sure. That is what I am here for. So see what happens. See, please try to understand this. So when we are having an equation like this, that x is equal to a plus bt plus ct square plus dt cube upon e plus t. So each of the term will have the same unit and dimension as of the other terms, right? See, if I ask you that can you add 100 rupees with 10 minute, you would say, sir, what rubbish, isn't it? How we can add rupees with the time, right? So this is basically a very common knowledge that you can add two things only, or you can subtract two things or two quantities only when they have the same unit and hence same dimension. Okay, so simply see how we have to do it. So dimension of A must be equal to the dimension of X. Right. So the dimension of X is what? So it is representing the displacement, that is length. So dimension of A is going to be L. Okay. Now similarly, the dimension of BT, the dimension of BT is again equal to the dimension of X, so it will be L. So what is going to be the dimension of B? So the dimension of B is going to be L T minus 1. Right. It is going to be LT minus 1. Right. Now similarly, what will be the dimension of C? The dimension of C. So dimension of C will be C. How much? So dimension of X is L. Right. And it is T square. So it will go in the denominator and it will become T minus 2. Right. So simple approach. Right. Now what happens to be with this one? So the dimension of this whole thing, that is dt cube upon e plus t, must be equal to the dimension of x. So the dimension of this whole thing must be equal to n. But now how we approach? So see, we have to use the common sense. Uni star. My dear, I didn't get what you want to say. Okay. So basically, see what happens. Shivram, how it helps you. So dimension of dt cube upon e plus t. So see, e added to t. So e can be added to t only when e can be added to t only when e can be added to t only when the e and t have the same dimension. So what is going to be the dimension of e? How does it concerns you, Shivram? If it is of any of your help, then definitely I would tell you. Okay. Okay, so see, since E is added to the T, so E and T can only be added when they have the same dimension, isn't it? So E and T can only be added when they are having the same dimension. So dimension of E is T, right? So the dimension of this whole thing is T. So can I write the dimension of dt cube is going to be equal to LT, right? Because the dimension of this whole thing E plus T is T only, right? So from here we can have the dimension of D and it will be L T minus 2, isn't it? Please answer me that. Yeah, what do you say? Did you get it or not? Please answer me. बोलिए. Please answer me. Okay, Tanu, you have got it. Right? So see, they will be asking you questions in this context from the principle of dimensional homogeneity. They may ask you all these things. So let's do one more question. Come, let's try this question. Let's try this one. All the live students, you may try this question. Often, I just so there is some technical issue. Can you guys hear me? So often आप एक मिनट, आप पूछ रहे हैं सर मैं PWD कैटेगरी का स्टूडेंट हूँ, मुझे नीट कितने मार्क्स चाहिए मैं पीटर हूँ, मुझे नीट में अच्छा अच्छा. So देखो बेटा, you must see first of all, see Afan, what I suggest you that you try to prepare for the maximum marks. Are you getting my point बेटा? तो देखिए होता क्या है कि मतलब बहुत ज़्यादा मतलब आपका मतलब आप समझ लीजिए लगभग 10 से 20% का डिफरेंस आता है जो मतलब मुझे लगता है. ठीक है, सो यू मस्ट प्रिपेयर योर बेस्ट, राइट. See, sometimes what happens now when we talk like this, we try to skip. So, is it like if I tell you this, so are you like thinking in a way that sir, I leave some topic, कुछ topic छोड़ देते हैं, मुझे तो इतना ही मार्क चाहिए, इस डायरेक्शन में जा रहे हो क्या? हाँ, बताइए. So देखिए, टू आंसर दिस क्वेश्चन सिंपल सा है. देखो, सबसे पहले तो बिल्कुल मैं आपको ये एडवाइस करूंगा कि आप बेटा कोई भी टॉपिक छोड़ के मत जाना. मतलब ये मत सोचना कि आप कोई टॉपिक छोड़ दो, है ना. लेकिन अगर मैं बोलूँ तो 20 to 30% स्कोर कंपेयर टू अ जनरल कैटेगरी स्टूडेंट, एक जनरल कैटेगरी का स्टूडेंट से उससे आपको लगभग 20 to 30% स्कोर में बेनिफिट मिलता है. 20% का लगभग आपको बेनिफिट हो जाएगा. गेटिंग माई पॉइंट? ठीक है. मतलब अगर पीछे सालों के डाटा के हिसाब से देखें तो अब अगर आपके 500 550 करीब स्कोर होगा तो गवर्नमेंट कॉलेज में एमबीबीएस की सीट आपको मिल सकती है. ठीक है. एनीवे, चलिए लेट्स सॉल्व दिस क्वेश्चन. So see, this question is a question of this context only, right? जो हमने dimension पढ़ा, it is from, okay, so Tanu, you have answered something. Okay. What are the rest? What about the rest of your students? Akash, hello. Very good afternoon. My name is Dr. Shankar Sir, and we are trying to have a revision. Okay. So would you like to try to this question? Mayank have answered something. So see how we can do it. So it says an equation given as P plus A upon V square is equal to B theta by V, where P is the pressure, V is the volume, theta is the absolute temperature, and A and B are constant, then dimension of A will be, the dimension of A will be. So see, P plus A by V square, okay, P plus A by V square is equal to b theta by v. Okay, so now they are asking you the dimension of A will be. So see what is going to be the dimension of A. So see, obviously, see these two terms are getting added. Okay, so they must have the same dimension. So can we write the dimension of A by V square is equal to the dimension of P, and P is the pressure, right? So see, dimension of P is what? So it is force upon area, so MLT minus 2 upon L square. So what is the dimension of A? So the dimension of V square will be L to the power 6. So the dimension of A is going to be ML to the power 5 T minus 2. Okay, understood? ML to the power 5 T minus 2. I hope it is fine to everyone. Yeah. So that becomes the B option. So see, this is one type of question that they ask you quite frequently in this particular chapter, right? And like, see, a few things that you must be able to realize that. So, like, suppose, let's suppose this is the question. Now, if they ask you the dimension of alpha, what would be the dimension of alpha? Can you guys tell me what will be the dimension of alpha? What would be the dimension of alpha? Can you answer me, guys? What would be the dimension of alpha? Come on, guys, try to tell me. And all the new students, beta, I'll request you to also subscribe the channel. Sonia and hello, welcome to the session. Very good afternoon. My name is Dr. Shankar Sir, and I welcome you to the channel. In this session, we are trying to revise few chapters of the physics. Yes, Sony, good afternoon. It seems to me that you are coming to this channel for the first time in my live session. Please try answering it. Yeah, I'll wait for one more minute. Because see, this is a revision session. So we had the question session in which we had solved quite a few questions. So what will be the dimension of alpha? See, again you have to use your common sense there. Please try to do. Please try to do that. Bhatto. Very good afternoon, my dear. Welcome to the session. My name is Dr. Shankar Sir, but I'm just waiting for Tanu to answer. She asked me to wait. Okay, I'll continue. So this question we have to answer. So P is equal to P naught e to the power minus alpha t square. So we are asked about the dimension of alpha. We are asked about dimension of alpha. Okay. Then you have answered t square. Okay, I'll see. So now see how you can find the dimension of this thing. So for that, see what you have to do. So you have to use some common sense. So how we are be using the common sense? So see, it is e to the power something. So when something is in the power, it has to be a number, no? It has to be what? It has to be a number. Now, if it is a number, then its dimension must be what? It must be dimensionless. Any number, any constant. Okay. See, not all the constants are dimensionless, but the constants which represent a number, these are having no dimension. So the dimension of this thing must be m0, l0, t0. Okay, so what shall be the dimension of alpha? It must be t minus 2, right? M0, L0, t minus 2. So see, in these kind of a question, you have to use a little of your general understanding to solving the problem. Okay, to solve the problem. So see, from the dimensional homogeneity, they can ask you such questions, and this is very frequently asked. Now, one question that they ask you is relation between different physical quantities. Okay, so see, dimensional analysis is a way to identify. Dimensional analysis is also a way to identify the relation between different physical quantities. Like, for example, if I ask you that let's suppose the time period of pendulum depends upon, so this is time period depends upon mass, okay, let's suppose m, length, let's suppose L, and g, that is acceleration due to gravity. Okay, so this is information is given to you and you want to find out the relation between these quantities. You want to figure out the formula of this, okay, or the formula of t in terms of these three, right? So how you can approach it, how you can find it. So again, we can use the concept of dimensional homogeneity. So how we can begin? So we can say that T is proportional to, so it depends upon mass, length and G, right? So mass to the power A, L to the power B and G to the power C. Okay, just you can write X, Y, Z also, whatever you want. Now, what is going to be the dimension of the time period? So it is t, right? Then, what is the dimension of this mass? So this is m. What is the dimension of this L? So it is L only. And what is the dimension of this G? So it is LT minus 2 to the power C. Now what we can do, we can compare the powers of the bases on left and right hand side. So A is right away 0, A is right away 0, B plus C is 0. Sir, how come, sir? Because see, when we are writing this T, can I write M0, L0 also? Okay, makes no change. So A is equal to 0 and B plus C is equal to 0 and minus 2C is equal to 1. So C is minus 1 by 2. C is minus 1 by 2. Right, C is minus 1 by 2. So B will be 1 by 2. So what we can get? So T is proportional to M to the power 0. So M is gone. L to the power B. So root L. Okay. And G to the power minus 1 by 2. So root G. Right. So T is proportional to root L by G. So you can say that T is proportional to K times root L by G. Okay, so this is how you can relate between different physical quantities if you want to understand the dependency of it. So see, there is some limitation to this formula, obviously. So you cannot find the value of k. Later on, when you do experimentally, we get this famous formula, no, 2 pi upon root L of g. Yes or no? Right? Please answer me. Right? Okay. Now this helps you, this approach helps you in finding, uh, doing many problems. So I'll just give you one small problem so that you can get the context well. So the live students may try this question. Just one question. We'll try to be a little bit quicker today. Please do. Any live students who want to answer? Please answer it. Any answers, guys? Okay, I'll do. So Tanu, you have answered something. So it says if energy, velocity, and time are chosen as the fundamental quantities, the dimension formula of surface tension. So in this question, what is the context to this question? So in this question, what they did, they have changed. They have changed the fundamental quantities. They are saying now that energy, velocity, time are the fundamental quantities. So the dimensional formula of the surface tension will be, okay. So see how we can do. So surface tension we can say, sir, it is proportional to energy, it is proportional to velocity, and it is proportional to time, because ultimately we have to relate those. Okay. So what is the surface tension? It is force per unit length. Okay. So it is mlt minus 2 upon L. So this is mt minus 2. Now what is the dimension of energy? Sir, it is force into distance. Okay. It is force into some distance, Newton meter. So Newton meter means that it is m L t minus 2 into L. So it will be ml square t minus 2. It will be ml square t minus 2 to the power a, right? Velocity is lt minus 1 to the power b, okay? And this is t to the power c, right? So it will become mt minus 2, and this is m to the power a, L to the power 2a plus b, and t to the power minus 2a minus b plus c, minus 2a minus b plus c, okay, minus 2a m to the power a, L to the power 2a plus b, and t to the power minus 2a minus b plus c, right? So from there what we can do, we can compare the powers of the same basis on the left hand and right hand side. So a will become 1, 2a plus b will become 0, and minus 2a minus b plus c becomes minus 2. So from here a is 1, so b is minus 2, b will become minus 2, and if we put it here, so it will be minus 2, it will be minus 2, and this will be plus 2 plus c minus 2. So from here c is also minus 2. So we got it now. E v minus 2 t minus 2. So that is the B option. So now they will be asking you these kind of a questions, and I hope that you will be able to deal with those. Yes or no? Yeah? Will you be able to deal with this or not? Please answer me. Aditya, welcome to the session. My name is Dr. Shankar Sir. So, beta, you got this question? Yeah? So these ways they are asking the questions. So would you like to try one more? So let's try one more. Huh? After that we'll move to the significant figures and errors. So beta, in this session I'm trying to give you a full revision of this whole thing. Let's try this one, guys. Answer it, beta. Yeah, waiting only. Any answer, guys? All the live students, you may try to answer me. So it says if dimension of, I'll do it, huh? If dimension of critical velocity v of a liquid flowing through a tube are expressed as eta to the power x, rho to the power y, r to the power z, where eta, rho and r are the coefficient of viscosity of liquid, density of liquid and radius of the tube respectively, then the values of x, y, z are. So again, how we can do it? So see, it says that the velocity is proportional to eta to the power x, rho to the power y, and r to the power z. Okay, r to the power z. Okay, so this is going to be LT minus 1. Right, so what is this eta? Eta is coefficient of viscosity. So we just now have found the coefficient of viscosity, no? The formula, right? M L minus 1, T minus 1. So we can use that. M L minus 1, T minus 1 to the power x. Okay, density is kg per meter cube, so it is ml minus 3 to the power y, and this is l to the power j. This is l to the power j, right? This is l to the power j. So from here what we can do, so we can write x plus y is equal to 0. Okay, we can write minus x minus 3y, minus x minus 3y is equal to 1, sorry, minus x minus 3y plus z. Okay, because this is also there, na? So minus x minus 3y plus z is equal to 1, right? Is equal to 1, and so we are comparing the power of the same basis, right? And t to the power minus x is minus 1, so x is equal to 1, x is equal to 1, so x is equal to 1, so y is equal to minus 1, right? So you got the sorry, you got the solution right away, isn't it? So x is -1, y is -1, so we are having only one option that is left, that is B option, right? So see, in this first chapter, this is 1 June where they talk about this. This is 1 June where they talk about the dimensions and all, right? Now there is one more June, that is of the significant figure and the errors. Okay, so see, all the live students, guys. So see, this is a revision section. So I am going to have a quick revision on the things. Okay, this is now not a full-fledged session, right? So I have explained. So if you are following this channel, if you have subscribed this channel, okay, so you will see that there are you will find that there were sessions in which I have dealt with all these in very much detail. Okay, now what is the significant figure? Okay, so see, now we are talking about the measurement. So see, one thing is though, so see, when you are measuring something, when you try to measure something, what is going to happen when you are measuring something? What is going to happen? What is going to happen? So see, no matter how you try, how hard you try, see, you will never be able to measure with 100% accuracy. There will be, this is not possible, right? And here comes the concept of the significant figure or the significance of the significant figure. See, in the significant figures, what happens? In the significant figures, guys, what happens? In the significant figures, so when you are writing something, when you are writing some value, let's suppose you have measured something and you have measured it as 1.13113 meter. Okay, okay. So significant figure basically describes about that how much numbers, how much digits that you are 100% sure of. Okay, right. So when you have measured something from some instrument, you might have, let's suppose that we have get the value or we have found a value of 1.113 meter, right? So significant figures means the number of digits, the digits we are, the digits we are, the digits we are 100% sure about. Okay. Okay, so see, there are some rules of significant figure. So when I talk about the significant figure, there are a few things that needed to be talked upon, or a few things which from where the questions are getting asked. So first of all, there are rules to find the significant figure. They can ask you that what is the number of significant figure in any particular thing, or you must know that. Okay, you must know that. From the rules, after the rules, we move to the algebra of the significant figure. That means rounding off. Okay, how do we round off the significant figures? How do we do the subtraction and addition of significant figure, and then further multiplication and division of significant figure? Multiplication and division of significant figure. Okay, multiplication and division of significant figure, right? So this is how we talk about it in this particular thing. But before I move to the significant figure, let me see that how much you understand the significant figure. So see, if I ask you that 4.0 kilometer is equal to 4,000 meter, is it equal to, so guys, before we move ahead, I want you to answer this question. What do you think, all of you? Aditya, Tanu, all of you. What would be you? What would be your option? What would be you selecting here? Please answer. So Tanu have answered something. What about the rest of you? Tanu is saying all are correct. How many of you are agree with Tanu? Please answer me. How many of us are agreeable or agreed to Tanu? Please answer me now. Please answer. Any live students? So see, how can we do it? So now, first of all, I tell you. So see why. Now, how the students see it? So they see it like this. So 4 kilometers, and we know in 1 kilometer we have 1,000 meters. So 4,000 meters is 4.0 10 to the power 3.4 into 10 to the power 4. All are the same thing. All are the same thing, right? So the answer should be all are correct. So this is not the right answer. Right, so the right answer is B option. Why the right answer is B option? I tell you now. So see, in this, surprising, no? Huh? Surprising, no? So guys, when many students see this question, they think that the right answer to this question is all are correct, right? Why they are thinking that all are correct? So they think that 1 kilometer is equal to 1,000 meter. 1 kilometer is equal to 1,000 meters. So when 1 kilometer is equal to 1,000 meter, that means 4,000 meter must be correct. That means 4.0 into 10 to the power 3 meter must be correct. Zero point 0.4 into 10 to the power 4 meter also correct, because it seems to you that these all are the same thing, and we answer all are correct, which is wrong answer. The right answer to it is, that is the B option. So see, this question has something to do with the significant figures, right? Now, in the case of significant figures, see how this significant figures is going to help you. Right. So see, from the concept of significant figure, when you are converting the units, see there is one rule in the significant figure. So when you are converting units, number of significant figures must not change. Number of significant figures must not change. Okay, so if you have read, if you have gone through the significant figures concept or chapter, you must be knowing it that we cannot change the number of significant figures during the conversion of the units, right? Okay, so now if I see in this 4.0 kilometer, what is the number of significant figures? Sir, we are having two significant figures. Sir, how come we are having the two significant figures? For that, we must understand the rules of significant figure. Okay. So 4,000 meters, so how many significant figures are there? Sir, only one significant figure there. In this, how many significant figure there? Sir, two significant figure. Sir, how we are understanding that there is only one significant figure, two significant figures? So for that, you must go through the rules of identification of significant figures. See, if I see the first one, if I see the 4.0 kilometer, so see any non-zero digit is a significant figure. And if the zero appears after the decimal, that is also a significant figure. So in this case, 4 is non-zero. And after the decimal, since the zero is appearing, this is ending zero. Okay, so ending zeros are significant when they appear after the decimal. So this zero is also significant. Now in this first case, in this first option, 4 is a significant figure because it is a non-zero. And these three zeros in the end are not significant. So why they are not significant? So they are not significant, guys, because they are not significant because these are the ending zeros and they are not after the decimal. Okay, so there is only one significant figure here. Here in this case, see, 4 is a significant figure. 0 appears after the decimal and it is the ending 0, so it is also a significant figure. So two significant figure. 10 to the power 3, that is order of magnitude, is never significant, so it has only two significant figure. In the third part, guys, what we are having, in the third part we are having 0.4. So it is having how many significant figure? This is having one significant figure because see, 4 is a non-zero digit. Okay, so it is a significant and zero. So initial zeros. So if you go through the rules, you get to know that initial zeros are never significant. So this zero is never significant. And 10 to the power 4 again. 10 to the power 4 again is also not a significant figure because this is the order of magnitude. So in the third option, we are only having one significant figure. So in general context, when you see it like this, 1 kilometer is 1000 meter, it appears to you for many students that's all must be correct, but which is not true. The correct option is B option because when you are converting the unit, when you are converting the unit, so during the conversion of the unit, you must make sure that the number of significant figures are not changed during the conversion of the unit. So the answer to this question is the B option. Okay, so significant figures helps you in conversion of units and in the analysis of the errors, and it is a very very important topic. Okay, so just a moment. Okay, got it, bruh? Alright, so now what are the rules of significant figures? Let's check that. Let's see this. So I'll just give you the rules like this. So as I've been speaking, Okay. So these are the rules of identifying the significant figure. Okay. So what are the rules, guys? So the rules are, see, I'll just give you the rules. So non-zero, and afterwards we'll identify the number of significant figure in some, numbers in some, digits, and we'll be good to go. So non-zero digit are significant figure. So in any number, the non-zero digits are all the non-zero digits are the significant figures, right? Right. Now the trap zeros are significant figures. I'll just explain. So just have a read to it, and I'll just explain you. Okay. So let's say, so just have a read. Trap zeros are significant figures. Okay, so what we mean by the trap zeros? So the zeros which are between two significant figures are the trap zeros. Okay, initial zeros and leading zeros are never significant. Okay, trailing zeros or ending zeros are significant if they appear after the decimal. Order of magnitude is never significant. Okay, while converting the unit of significant figure must not change. So we just use this rule. Constant in formula has infinite significant figure. So in any formula, if the significant figure, if any formula, if the significant figures, okay, in the significant figures, uh, so see, in any formula, if there is a constant, the constant have infinite significant figure. Okay. Okay, so let's see. Let's apply the rule in finding out the significant figures. So let's suppose we have 2 point. Just a moment, guys. Huh? Okay, so just a moment. So I'll write some numbers and you have to tell me what are the number of significant figures in each of the number. Okay, 2.123, 2.001, 0.0020, 0.02002. So just randomly I'm writing. So you have to tell me the number of significant figure with each of these numbers. What are the number of significant figures? Please try to tell me, Vida. What are the number of significant figures? Please do. Please do. Please try to tell me. Hello, Vishal. How you are doing? So, see, guys, we are trying to revise few chapters of physics, my dear. And see what I asked. I asked the number of significant figures in each of the following digits. Please answer me. What are the number of significant figures in each of them? What is the number of significant figure in each of them? Very good, Vishal. What about the remaining one? Wonderful. Tanu, you also answer. Hmm. Very nice. Vishal, can you please check the fifth one again? Can you please check the fifth one again? Vishal, can you just cross check the fifth? Okay, okay. Let us check. So, see, Tanu, it is not very difficult, beta. See, in the first one, 2.123. So, how many significant figures are there? So, four significant figures are there. How? Because all the non-zero, what is the rule? All the non-zero digits in any number are the significant. So, this is 4. Now, see, here in this 2 and 1 are the significant figure. Okay, 2 and 1 are the significant figure, and these two zeros are trapped between two significant figures, so they are also significant figure. So it seems to me that that is wrong, Vishal. So this is 4 significant figure. Now how many significant figures are there? So see, trailing zeros are never significant. Trailing zeros are never significant. Okay, so trailing zeros are never significant. That means these three are not significant. Right. Now this 2, this is a non-zero. So this is significant, and this 0, this is the ending 0. And ending 0 is significant if it appears after the decimal. See beta, very very simple. देखो simple सी कहानी है. It's very simple. Okay, trailing 0 तभी मतलब ending 0 जो आखिरी वाले 0 होते हैं, the ending 0, the last zeros are only significant if they are after the decimal. If they are not after the decimal, they are not going to be significant. Like 2000. Okay, so these what we call are the ending 0, but these are not significant. Why? Because there is no decimal. Okay, so in this only one significant figure. So see how many significant figures will be there? So 2 significant figure. Okay, now in this one, see, train leading zeros or the beginning zeros, initial zeros are never significant, so this can't be significant. Now this 2 0 0 2, so these two are significant and these two zeros are the trap zeros, so this must be significant, right? So it will have 4 significant figure. Now in the fifth one, Vishal, I think this you have given the wrong. So 5 is significant, 1 is significant. Now these two zeros are significant because these are trapped, and this zero is also significant, na? Because this is ending 0 and it appears after the decimal. So it is 5 significant figure, right? In this 4 significant figure, see, order of magnitude is never significant. Order of magnitude is never significant. Now in this, how many significant figures are there? So 6 significant figures are there. And in this, how many significant figures are there? 5 significant. Because see, initial 0 will never be uh, significant, and the remainings are the significant one in this case. Is it fine, brother? Yeah? Did you get it? Tanu? You also? Okay, Vishal. So now this is how significance figure works. Now let's come to the rounding off. See, rounding off of significant figure. Rounding of significant figures. Okay. So see, sometimes when we do the calculation, when we do the calculation, we need to do some rounding off as well. Okay. Now see how we are going to round it off. So see, I'll just explain quickly. See, 4.67, let's suppose 3.96, okay, or 3.76, right? We can have any number. Let's suppose we are having 5.29, we are having 5.24, we are having 5.36, we are having 5.41. Okay, so you need to round these off to the two significant figure. Right now, all these are having how many significant figures? So these are having three significant figure. So see, this is very easy. This I'll do. See what happens. So see, you need to round off to two significant figures. That means you want to make two significant figures out of these three significant figures. So when we'll do the round off, see what you are going to write, sir, 4.7. Now see why you have raised this 6. Right, because see the number, so this is see, when you are rounding off the digit, you are going to see the digit next to it. Rounding off is very simple, no? Okay, see, when you are rounding off any digit, you are going to see the next digit. Okay, so the next digit here, you see if it is greater than 5. See, 5 is the hero here. Number 5. Okay, so the number 5 is hero. So if this digit is greater than number 5, yes, Vishal. Okay? Yes, Vishal. Okay? So this is going to be 4.7. This is going to be 3.8. This is going to be 5.3, not 5.2. This is going to be 5.2. This is 9 actually. I think you have read it like 4. This is going to be 5.4 and this is going to be 5.4. See what happens. So if the digit after the number you are rounding off is more than 5, if the digit after the number, if the digit you are if the digit after the number you are rounding off is greater than 5, you are going to raise it. Otherwise, you keep it the same. See, when you are rounding off, you can do only two things. Either you can raise the number or raise the number by 1, or you can keep it the same way. Okay, you can keep it the same way. Understood? So this is going to be 4.7, 3.8, 5.3, 5.2, 5.4, 5.41. Understood, Vishal? And Tanu? Please answer me, beta. Easy peasy, no? Okay. Now the problems comes that when the number is exact 5. Okay. The problems comes when the number is exact 5. Like for example, if I ask you that if I want to have, see what will happen when the number, the digit after the digit you want to round off is exactly 5. Okay, if it is exactly 5. Okay, if exactly 5 is the number, then how it is going to work? Okay, so see, so if the digit is exactly 5, so let's suppose we are having 5.151. Okay, we are having 5.151, or let's say 6.252. We have any number you can write, 1.353, anything 0.454 or 0.454, chalo, 1.359, 1.357, anything like that. Okay, now in this you need to do the rounding off to two digits, so you have to round off to two significant figures. You need to round off to two significant figures. So when you need to round off to two significant figures, that in the first case, see, so which number you need to round off? So we need to round off. So when we need to round off to two significant figures, so we need to round off to, we are supposed to round off these digits, isn't it? We are supposed to round off these digits. Okay. So when we see the digit after this digit, that is 5, exactly 5, not more than 5, not less than 5. So when it is exactly 5, how would you be deciding on that? How would you be deciding on that? That whether we need to increase this particular digit or we keep it the same. So how we are going to do it? What will be the rounding off? Tell me. And uh, Vishal. So see, how we are going to do it. So see, when the number is exactly 5, when the number after the digit that you need to round off is exactly 5, so this will become C. Now see, you are going to see the number next to that number. So this is going to be 5.151, 6.252, 1.353. Okay. So so after 5, if there is a non-zero number, after 5 there is a non-zero number, so you just have to increase it. So you don't have to see whether it is what number. If it is non-zero, see, very simple, if it is non-zero, you can increase that digit that you're supposed to or you want to round out. Are you getting my point, beta? So it will become like this, right? See, you are going to, so if after 5 we are having another digit which is non-zero, you just have to see whether it is zero or non-zero. You don't have to see whether it is more than some number or less than some number or something like that. You just have to see whether it is a non-zero digit. So whenever it is a non-zero number, a non-zero digit, you just increase the number. You just increase the digit you want to round off. Understood, beta? Understood? Yes or no? Please answer me. Right? So if the digit after the digit you want to round off is exactly 5, if exactly 5, you can deal with it. Right? But what happens if it is exactly 0? What happens if it is exactly 0? So what will happen if it is, let's suppose, 5.150 or 5.250, and I need to round off to two significant figure. Now how I am going to do it? Can you tell me, Bra? Can you tell me what will be the round off of this? Vishal and Tanu, and any other live students who is present in the session, you may also answer it. Please do. Please do. Can you tell me? So now, see how we are going to do it. So, sir, after it, it is 0. If it is a non-zero number or non-zero digit, we would have raised this digit by 1. But this case, we cannot do that. So now see how we can understand it. So see, this is 0. Okay. So this is of no help. So now we have to see this digit, the digit that you are rounding up. If it is odd, you are going to raise it by 1, right? Remember it. People confused in it. Okay. And if it is even, okay, so if it is odd, raise by 1. And if it is even, keep it same. Okay, keep it same. Okay, so we are going to keep it same as 5.2. Understood? So see, whenever we are rounding off, simply whenever we are rounding off, basically what we do, we have only two things to do. We have only two choices, either to raise that digit or to keep that digit as the same. Okay. Okay, so if the number is more than 5 or less than 5, then it is very simple. But if it is exactly 5, then we have to do like this. Okay, okay. Now let's talk about the rules of addition and subtraction. Got my point now? So see, it is very, very simple. Only a few things that you have to understand. See, I just took the screenshot to save some time. Yeah. Now see. Now see guys. So what are the rules of addition and subtraction of the significant figures? What are the rules of addition and subtraction of the significant figure? So the rules of addition and subtraction of the significant figure is, first of all, whenever you are adding or subtracting two significant figures, you first of all do normally. Okay, do in the same way as you do in the same way as you do the normal addition and subtraction of two numbers, right, or two figures. Okay, so first thing is that you do normally. Afterwards, when you do normal addition or subtraction, you will get some result. Now that result you need to do the rounding off. Now, important point is to same decimal places as present in the value with least decimal places. So when you are adding or subtracting, two significant figures, the final solution must have only number of significant figures, only number of significant figure. Uh, uh, Only the number of significant figures, or it must have, see, or I say that when you are adding or subtracting the significant figures, you need not to focus on the number of significant figures, rather you must focus on the number of decimal places the value is having. Okay, the value is having with least decimal place. Are you getting my point, beta? Okay, so rules of addition and subtraction. So first of all, you need to do normally. Then the result must be rounded off to same decimal places as present in the value with the least decimal place. Right? Like for example, if I do some addition and subtraction, so let's suppose I'm doing some addition, I'm doing some subtraction. So now what I'm going to get? The live students, please answer me. What I'm going to get here? Hmm? What is going? Tanu, yes, yes, will do. Will do. Don't worry. After I finish this, will do. Okay. So what we are going to do? See, very very simple. Now in this case, see, when I add 3.39 with zero point 0.4, what we are getting? We are if we add generally 3.39. So first of all, you do the normal addition. Okay, in the examination you can do in your mind only. So this is 3.79. Okay, but this is not the final answer. Why? Very good afternoon, reality. My name is Dr. Shankar Sir and I am a physics educator. So I'm trying to give you a revision on the chapters that we have done on this channel. Okay, so this is what going, that is what happening. So see, now when we have added these two significant figures in a normal way, we get 3.79. But this is not the final answer. Why it is not the final answer? Because see, it is having it is having two decimal places after, it is having two digits after the decimal. And how many digits it must have in the final solution? So it must have only one digit after the decimal. Why so? Because see, when there are two significant figures out there, that is 3.9 plus zero point 0.4, when we add them, the final solution must have the same number of digits after the decimal as present in the value with the least decimal. So two values are there. Obviously, zero point 0.4 is the value with the least decimal. So you are going to get 3.8 here. Now similarly, if I subtract this 4.212 with 0.31, so see, we will be getting how much? We will be getting 3.3. Let's do 4.412 minus 0.31. Okay, so we'll be getting 0, 0, 1, and 3. Sorry, and 4. Isn't it? So we'll get 4.102, right? 4.102. So what we must do, sir? We must be reducing. So this must not be the answer. This couldn't be the answer because we must have only two decimal places in the final answer, as the value with the least decimal place is, okay, so you couldn't see it. Just a moment. So when you actually subtract it, you will get, I just subtracted. So you get 4.102. 4.102. But this couldn't be your final answer. Why? Because the final answer shall have the number of decimal places, as equal to the value with the least decimal place. So the least decimal place is having two digits after the decimal. So we'll be getting 4.10. I hope it is fine to everyone. Okay. Okay, so this is how we can, do the addition and subtraction. Now talking about the multiplication and division. Okay, so in addition and subtraction, take note that the final solution must have the only that number of decimal places that is present with the value with the least decimal place, right? Now talking about the rules of multiplication and division. Now talking about the rules of multiplication and division. So again, the first thing that you have to do is you have to do the normal way. You have to do normally. Okay? You have to do the multiplication and division in the normal way. Right? Now when you do multiplication and division in the normal way, what you are going to get? You are going to have some value. Now then you have to round off that value to same number of significant figure as present in the value with the least significant figure. So during multiplication and division, during multiplication and division, you need to do the rounding of equal to the same number of significant figure as present in the value with the least significant figure. Okay, like for example, if I do multiplication of two things, let's suppose 2.1, if I multiply 2.1 with 2.1. Okay, so you do the normal multiplication. So when you do the normal multiplication, you are going to get 4.41, right? We are going to get 4.41. But can it be the answer? No, sir. We have to reduce this answer. We have to reduce this answer to the same number of significant figure as present in the value with the least significant figure. So both are having how many significant figures, sir? This is also having two significant figure. This is also having two significant figures. So final answer must be having two significant figures. So when you will be rounding off, you must be careful with the rule of the rounding off. Understood, beta? Understood? Now see, if we are dividing, that is 0.9 divided by 4.26, right? So now if we divide, so like in general, if we divide, we'll get 0.21. Okay, when you divide it, you will be getting 0.21126. 0.21126. So it is actually 0.90. 0.21126, right? So now this couldn't be your answer. So what should be the answer? So it should be 0.21. Why 0.21, sir? Because the final solution must have the same number of significant figures as present in the value with the least significant figure. Okay, so what is the least significant figure? So 0.90 has the least significant figure, isn't it? Isn't it? So so very important. See, when you are adding, subtracting, okay, so many times you will see the questions on these concept. I'll just show you one. Okay, please try to do. Please try to do, beta. I'm very sure we can do it. The live students, all the live students, you may try to answer it. Hello, Narendra. My name is Dr. Shankar Sir, and I'm trying to give you a revision of the chapters we have done on this channel. So can you please try answering it? Yeah? What is the answer to this? Oh, you don't know. No problem, beta. So that is what we are trying to do. So see, on this channel, Render, we have completed this chapter, units and measurement, motion in a straight line, motion in a plane, basic mathematical tools, vectors, properties of solid, and I'll be soon starting with a new chapter of fluid mechanics. Okay, or the properties of fluid. Okay, okay, there we'll talk about the Bernoulli and everything, right? So in this session, I tried to give you a revision of what we have done till now on this channel. So we have been talking about the units and measurement till now. So see, significant figure. So we just have spoken about the rule of addition and subtraction, right? So see, when you are adding or subtracting two significant figures, right? So see, how many significant figures are there in this? We are having three significant figures. We are having three significant figures here. And how many significant figures are present in this? Sir, we are having two significant figures present here. Right? Two significant figures present here. So the final answer must have the same number of, sorry, the final, so not the significant figure that you must see. Actually, this is subtraction. So when you are subtracting or adding, when you are subtracting or adding, see, the final solution must have the same number of decimal places as present in the value with the least decimal places. So you need not to even solve it, right? Because see, after the decimal place, there must be only two digits. Okay, this is what the rule says. Right, two significant figures when subtracted, the final solution must have the same number of decimal places as present in the value with the least decimal place. So see, 9.99, how many decimal places are there? 2. How many decimal places are there? 4. So final solution, final answer must have only 2 decimal places. So that is your A option. Did you get it, Buddha? Yeah? Did you get it or not? Please answer me. Yeah? Please answer me. Right? Got it or not? Yeah, then we'll be just having a break. No worries. So guys, now significant figures are also over. So now we need to talk about the errors. Okay. So Narinder, do you have any answer? Did you get it or not? So see, this session has been we have been learning from last 2 hours and 30 minutes. So I guess we can have a 15 minutes break now. Okay. Okay. Right. So after the break, so we can have okay. So 10 or 30 minutes will be too much. So let's do one thing. We'll resume. We do one thing. So we'll have a lunch break also. No worries. And we'll resume the session at 2:30. Welcome, Ashna. So it's been a long session. So I think it's time for lunch also. So session resumes at 2:30 p.m. Okay. So I'll resume the session at 2:30 p.m. You have your lunch. I'll also have my lunch, and afterwards we'll study more. Let's see till what we can, you know, learn. Okay. So what I am planning to do after the session. So see, after so units and measurement, only few things are left. Errors and its measurement. That is a slightly simpler topic. Vernier caliper screw gauge is something that you must see from the descriptive session. Okay. So I'll not be covering those in this session, right? And afterwards I'll start with the kinematics. Okay, so motion and vectors also I'm not going to, because vectors already I have completed in one short session. So I'll just give you the kinematics. So this is a big chapter actually, units and measurement. This is relatively a big chapter. So after the break we can do some revision of the kinematics. So I hope you will guys will be back after the break. Okay, so let's see each other at 2:30. Right, all the live students, I request you to be at come at 2:30. Alright guys, so welcome back. Now we can resume the session. Okay. So guys, we had a break of few times and now we can continue the session. So the live students, so welcome back to the session guys, and we had our break. I think we had a lunch and everything, and now we'll be resuming the session from where we left. Okay, so we have spoken about the uh, we have spoken about the significant figures till now in this session, right, beta? Isn't it? So we have spoken about uh, the significant figure. Okay, so we have spoken about the significant figure, and now let's continue our discussion with the errors. Okay, so see, so guys, whenever we are talking about the measurements, it is mandatory that we also do talk about the errors, right? Because remember, see, in this physical world, no matter how hard you try, you can never have the true value or the most accurate value of some physical quantity. You can never have, right? So no matter how hard you try, there will be some errors in the measurement. Okay, so basically in this particular part of this chapter, we are interested in finding out that what is the error, what is going to be the error in a particular measurement, and how we can deal with the errors, right? Like what is, so for example, like if we want to find the velocity, okay, so velocity we can do like, we know that the velocity is displacement. We know the velocity is displacement per unit time, right? Now to get the velocity, we need to have the displacement, we need to have the time, right? Now when we'll be measuring the displacement and when we'll be measuring the time, there will always be some error in the measurement of displacement and measurement of displacement and measurement of time. Obviously, there will be some error in the measurement of displacement and measurement of time. Now, what will be the error then in the velocity calculation? So, see, and any physical quantity may have some other physical quantity. Any physical quantity may depend upon some other physical quantity, right? Some other physical quantities. So, when you go and measure the physical quantities, you are going to talk about the errors in the measurement of these physical quantities, right? You are going to have some errors in the measurement of these physical. Sorry, I'm, I don't know. I'm having hiccups all of the sudden. Just a moment. Huh? Yeah. So see. So now in this particular part, what we need to do about, so see, we have to first of all try to find the true value, right? So this particular part, in this what we have to do, we may have to find the true value, then we have to find the mean absolute error, mean absolute error, okay, and then we need to talk about the propagation of error. the propagation of error. Okay, so in this session, I'll be teaching you this only, right? Because see, if you see the NEET questions, if you see that how the questions are getting asked, you'll see that there is a scope of question asking from the propagation of errors only, because when we have to find the calculation of true value or mean absolute error, it is slightly lengthier, although it can also be asked, right? So, sir, from where we can learn about this? So, on this channel, again, I would say that you can see detailed session of the errors and its propagation, and you'll get everything. So, since it's a one-shot revision session, it is a one-shot revision session, so I'll be covering to some extent only, right? So I be talking about the propagation of errors. Okay, how the errors are propagated. Okay, how the errors are propagated. How the errors are propagated. Okay, during the calculations, right? What is happen when the errors are added? Okay, so errors propagation means that we are interested in knowing that how the error propagate themselves when two quantities are added or subtracted, okay, multiplied or divide, okay, multiplied or divide, or you know, like when the quantities are raised to some power, okay, quantities are raised to some power, okay. Okay, so when we are having to talk about the propagation of error, basically we need to talk about these things, right? When the errors are, when quantities, two quantities individually having some errors, when they are added, subtracted, what is going to happen with their individual errors? Okay, are you getting my point? What is going to happen with their individual errors, right? Similarly, when two physical quantities are multiplied and or divided, or when a physical quantity in a formula, there are some powers in which the physical quantities are there, are present, right? Okay. Now, under such conditions, how the errors are going to be propagated? So let's suppose, see, let's suppose, let's suppose we have uh, so see, first of all, try to understand it. So as I said, there is no quantity that is without any error. That means that when you are measuring something, there will be definitely some error in that measurement. So what is the right way of presenting one dimension? So it can be, see how we do, 100 plus minus zero point 0.1, okay, zero point 0.1 mm, right? So this zero point 0.1 gives you, what is the meaning of this zero point 0.1? This zero point 0.1 is basically the error. It is basically the error in the measurement of this 100 mm. Okay, this is the absolute error we call. So this is actually the right way of representing something. Let's suppose this is 50 plus minus 0.05 mm. Are you getting my point, beta? Now see, what is this? See, as the, as this thing is, I think obviously it is telling you this. So when you are measuring this length L1, okay, what could be its dimension? The dimension could be 100 plus minus zero point 0.1. That is 100 plus zero point 0.1 or 100 minus zero point 0.1. So basically the value, the true value or the actual value of this thing is given like this, right? Right. So if these two parameters are there, let's suppose we are having two lengths only, okay, and now these two lengths someone has measured, and obviously during the measurement there will be some error. So individually they have this error. In L1, measurement, the individual error is 0.1. In L2 measurement, the error is 0.05 mm. Now, if we add these two, see, if we add these two, if we do L1 plus L2, what it will be? It will be 150. See, remember, now try to understand one thing. In addition or subtraction, whether two physical quantities are added, whether they are subtracted, whenever two physical quantities are added or subtracted, their errors are always added. Okay. So remember, like even two quantities are getting subtracted from each other. Even two quantities are getting subtracted from each other, beta. Okay, so even two quantities are getting subtracted, even two quantities are getting subtracted, it doesn't mean that their error is subtracted. So remember one thing, no matter what, if two quantities, if two quantities are being added, if two quantities are being added or being subtracted, if two quantities are being added or being subtracted, if two quantities are being added or being subtracted, what is going to happen? Their errors are always going to get added. Their errors are always going to get added. Now, what does that mean? So, see, L1 and L2 are added. So, what is going to happen? Their errors is going to be added. So, no matter what, whenever the two quantities are getting added or subtracted, you are going to add their errors. So, this will become 0.15. Okay, we are adding the error in L1, we are adding the error in L2, right? So L1 and L2 will become 150 plus minus 0.5, right? Now, what is going to be L1 minus L2? If I ask you, what is going to be L1 minus L2? Can you tell me that? What is going to be the L1 minus L2? Can you answer it? So what is going to be L1 minus L2, sir? So see what you do, you simply subtract or add the true values, the actual values. So these two, when you add or subtract, you will get 50. You will get 50. And see, these errors are always added. Okay, so see, don't get confused. Even in the subtraction, these two errors are going to get added. So see, what is the bottom line? The errors are always added. Errors are always added in whether it is addition, whether it is subtraction. Understood, beta? Whether it is addition, whether it is subtraction. Right? Okay, any issue? Any issue? No issue, sir. Now let's talk about the multiplication and division. So let's suppose we have some physical quantity which is given by the division or multiplication of two quantities. Let's suppose A and B, and we are having another physical quantity that is given as C by D. Okay. Now obviously A will be having some error. So can I write the A as A plus delta, A plus minus delta? Delta is the error, absolute error in the A. Okay, B will be B plus minus delta B. Similarly, C will be C plus minus. So this is the right way of writing A, B, C. So basically, see, this is how the question will look like. So you will have some physical quantities in your, expression in your formula, and the error in the measurement of each of these will be given to you, and then you need to find the error, cumulative error in the formula, or in finding the desired physical quantity. So D will be D plus minus delta D. D will be D plus minus delta D. So see how you are going to write it. So X is equal to A into B. X is equal to A into B. So see how you are going to write it. So see, very simple. We are going to use the rule of fraction. So delta X by X equal to delta A by A plus delta B by B. Very, very simple, isn't it? Delta A by A plus delta B by B. Okay, very, very simple. And see, so this is what we know as the fractional error. Okay, this is what we call as the fractional error. Right? So this is the fractional error in X. Okay, so see how they sound the question. And normally they ask you the percentage. So if I multiply 100 into it, it will become the percentage. So they will say, they will frame the question like this, that x is given as a into b, and the percentage error in a is this, the percentage error in b is this, percentage error in a is this, percentage error in b is this. Now, if this is the percentage error in a and b, what will be the percentage error in the calculation of x? They will frame the question like this. They may frame the question somewhat like this. Okay, so this is what we call as the percentage error. This is what is? This is the percentage error. This is what? This is the percentage error. So this is the percentage error in x. This is the percentage error in a. Right? This is the percentage error in b. Okay? In a. This is the percentage error in b. So they may ask you the percentage errors. They may ask you the percentage errors. So they may give you the percentage error in the, we can say dependent parameters, and they may ask you for the independent variables, right? So same goes for the division also. So if y is equal to c by d, if y is equal to c by d, if y is going to be c by d, what we can write? We can write c. Division also follows the same rules. So multiplication and division are following the same rules of error propagation. Addition subtraction follows the same rules for error propagation. So delta c by c plus delta d by d, it is into hundreds. So basically what we can write? We can write percentage error in y, percentage error in y. Okay, this is, and it is equal to percentage error in c plus percentage error in d. Very, very simple now. Percentage error in d. Right? All the live students, you may tell me, did you get it or not? Please answer me. Yeah? Please answer me. Yeah? Please answer me, guys. Yes or no? Okay? Okay. Now, if the quantities are raised to, so sir, one more thing. So what if it is written like this, 1 upon x is equal to 1 upon a plus 1 upon b, if any formula is like this, then how we can proceed? So see, again, we can do by the simple way. So I can do like this. So it will become ab, and this is a plus b, 1 upon x. So x is going to be ab upon a plus b, ab upon a plus b, right? Ab upon a plus b. So from here we could write delta x by x into 100 is equal to delta a by a into 100 plus delta b by b into 100. Okay, and now this a plus b, this whole thing, this a plus b, this whole thing will have some error. So we can write delta a plus b. See, this, you consider this as another quantity. Okay, and you write the fraction error to this. So what is the problem? No problem. Yes or no? All the live students, please answer me, Buddha. Right? Okay. Okay. Now, if the quantities are raised to some power, let's say that we are having something like this. Okay, we are having something like this. Let's suppose P is equal to Q square R cube upon S square. Okay, something like this is written. So here in this, the properties are, or I can write it like this, see, generalizing it. So see, we can say that it is written like, so let's suppose x is equal to a b by c, right? Now so let's say it is having a power of p, q and r, right? Now, when the quantities are having some power, okay, when the quantities are having some powers in an expression, then how can we be dealing with? Then how can we be dealing with the propagation of errors? Because see, again, each of these individual quantities like A, B, C, everyone, each of it quantity will have, each of this quantity will have some error into it. Okay, so how we are going to deal with the error? Okay, so A individually will have some error, B individually will have some error, C individually will have some error, right? So what will be the error in the measurement of x, right? So see how we can do it. So very simple. So we can write delta x by x into 100 it is equal to p times delta a by a into 100, p times delta a by a into 100 plus q times delta b by b into 100, okay, plus r times delta c by c into 100. So simply what you have to do, so whenever the quantities are raised to some power, whenever the quantities are raised to some power, you can do like this. Okay, okay, right? Any issue? I hope it is fine to everyone. Yeah, please answer me. Okay, so let's solve one question so that we understand this in a better way. Just solve, guys. Okay, so let's suppose we are having a physical quantity x. Okay, we are having some physical quantity x, and x is given as a square b to the power 1 by 2. Okay, b to the power 1 by 2 upon c to the power 1 by 3, c to the power 1 by 3, and d to the power 3. Let's suppose we are having some expression like this. Now it is given that the percentage error, it is given that the percentage error in A, B, C and D. And see, obviously the percentage error mission, or the percentage error you are interested in giving is the maximum percentage error. Getting my point? So percentage error in A, B, C, D are 1%, 2%, 3%, and 4%. Now we need to find the percentage error in X. What is the percentage error in X? Please go for it. I'm very sure we can do. Please go ahead. Please do it. Please do it. The live students, I'm very sure we can answer. Could you please do it? So see how we can do it. Very, very simple. See how we can do it. So it says the percentage error in x. Okay, so what is going to be the percentage error in x? So see how we can write. We can write delta x by x into 100. Okay, delta x by x into 100 plus 2 times delta a by a into 100. Okay, okay, plus half times, see this is how we can approach it, half times delta b by b into 100 plus 1 by third times delta c by c into 100 plus 3 times delta d by d into 100. Okay, into 100. So now we can write it. So see, it will become 2 plus 1 plus 1 plus 12. So it will become how much? It will become, sir, 16%. So what is the answer to this question, sir? The answer is 16%. So see, this is about the errors. I hope you have got this thing. Right? Okay, I hope you have got this thing. So guys, in this session, we have revised the first chapter completely. Okay, and see, though I wanted to revise the other chapters also, but I don't see that there are much live students in the session, so I'll not go ahead with this session anymore. So the first chapter is revised again thoroughly. So the live students who are present in the chapter in this session, okay, and it's been a very long session, so I think that the students are getting tired also. So I'll complete this session now. I'll stop this topic now, this chapter now, and in another session we'll have the revision of kinematics. Okay, okay. So guys, I hope you have enjoyed the session. You have revised this first chapter again for 1 year caliper for screw gauge. You can watch the sessions on this channel. You will get complete understanding of those, and that is the part of the units and measurement only. Now these days they are writing on the syllabus in the 28th unit, as a 28th unit, the experimental skills, right? But I hope you have got what I wanted to convey to you. So guys, with this, thank you very much. Have a good day, and we'll see you in the next session. And the new students, please don't forget to subscribe the channel.